Alright guys, so this is the second part of the 9.3 video, so if you haven't watched the first, please do that. This will make absolutely no sense if you don't. Okay, so let's look at example 2 now, and it says use the unit circle to evaluate the 6 trigonometric functions of 270 degrees. So if we were to draw 270 degrees in standard position, it'd be here, down, and we would stop here. Okay, right here on the y-axis. And if you remember, our unit circle has a radius of 1, so our point here would be 0, -1. Okay, now remember from what we first started out right here, okay, we knew that sine was y over r, cosine x over r, so on and so forth. Okay, so if we did that, here our y value is -1, our x value is 0. So if we did that, this would just be -1 over, remember the unit circle, our radius is 1. Okay, our cosine would be 0 over 1, and our tangent would be -1 over 0, which is undefined. Can't divide by 0. Okay, if we simplify this, this is just 0. If we simplify this, this is -1. Okay, now the cool thing about the unit circle is now that our r is 1, anything divided by r is itself. Anything divided by r is itself. So our y value will always be, and this is only if you have a unit circle, our y value will always be the value of sine, and our x value will always be the value of cosine. Okay, always, always, always. Okay, so that's pretty cool because here, now I can find cosecant. I know cosecant is 1 over sine, which is just 1 over -1, so -1. Secant is 1 over cosine, so 1 over cosine is 0, which is undefined. And my cotangent is the opposite of tangent, so 0 over -1, which is just 0. Okay, so once again, the unit circle is great because my x-coordinate is my cosine, my y-coordinate is my sine. All right, if you feel like you need more practice, please use these 3 and go ahead and work them out. Pause this, work it out, and then I'll show you what I got on. All right, so this is what you should have gotten on the first couple. Okay, you need to do Pythagorean theorem to find your radius. Or over here, you can use the fact that both of these sides are equal, so you know it has to be a 45, 45, 90 triangle. Okay, and then if we go down, this is the bottom one, so we're using our unit circle, so we'd find the point at 180, which is -1, 0. Remember our first one, our x-coordinate is our cosine, and our y-coordinate is our sine. All right, so we're talking about reference angles now, and reference angles are very important, okay? And this is what keeps us from having to remember all these things here, okay? So this is going to be much easier after you know reference angles. You won't have to memorize all these, like I said. All right, so first of all, a reference angle is formed by the terminal side and the x-axis, okay? So that's what you need to know. And a lot of times our reference angle is our theta prime. Okay, so if this is our theta, this is our theta prime. So like over here, if our theta is going from here to here, our theta prime is going from the terminal side to the closest x-axis, which is over here. Okay, here if we're stopping here, we're going from the terminal side to this x-axis right here. Okay, so this would be our theta prime. And over here, here's our terminal side, and our closest x-axis is here, so this would be our theta prime. Okay, now what's cool about this is if I had, I don't know, and I'm just going to make up numbers here, which might be pretty scary. Okay, this, and let's just say this is 0.34. Okay, and then that means that, I guess it'd be -3,4. So that means that this is 3 and this is 4, and we have a 3, 4, 5 triangle, so it's this. Okay, so our reference angle here, or our angle here and our reference angle have the same sine, cosine, tangent values. Okay, so remember before we said sine is y over r? Well, if you don't want to remember that, okay, we have our y over our r, which is 4/5. But if we look at this triangle outside of the x-axis, okay, 4, 3, this is our reference angle, 5. The sine of this is going to be opposite, which is 4, over hypotenuse, which is 5. Okay, so you can always use that reference angle and just find the 3 sides of the triangle. And the only thing you'll have to keep in mind is the quadrant you're in will determine whether or not these values are positive or negative. All right, so let's look at example 3 now. We want to find the reference angle for these two things. Okay, now I always like to put these on an axis because it's easier for me to see and draw them in standard position. Okay, so if I had theta, probably should have drawn that a little bit more, but that's okay. Theta is 5 pi over 3. Okay, and I know all the way around to here would have been 2 pi or 6 pi over 3. So this would be what's left of it, right? So I could say 6 pi over 3 minus 5 pi over 3, and that is just pi over 3. Okay, a lot of you guys are going to have more difficulties doing radians than you are degrees. Just, you're going to have to struggle through it a little bit and it'll get easier. Okay. All right, so if we look at B, okay, if I draw this in standard position, and this is a negative, so I'm going this way, we're right here. Okay, here's my terminal side. So if this is 130 degrees, my reference angle is going to go from the terminal side to the nearest x-axis, which is right here. Okay, so this angle here, well, if I went all the way, it'd be 180. So this is just 180 minus 130. So my reference angle would be 50 degrees. Now, if this is listed in radians, your reference angle should also be in radians. If it's listed in degrees, your reference angle should also be in degrees. All right, now if I want to look and determine what's positive and what's negative, okay? And this should make sense to you. You should be able to conceptually understand this as well. Okay, think of any point in quadrant. Remember, this is quadrant 1, 2, 3, and 4, right? So, woo. Oh, wow, that was exciting. So this is quadrant 4. So any point here would have a positive x-coordinate and a positive y-coordinate. Okay, and so everything in this would be positive. All sine, cosine, tangent, and the inverses of those are positive. Okay, over here, my x value is negative and my y value is positive. Okay, so if my x value is negative, my y value positive, remember, my x value is my cosine. Okay, so my cosine is going to be negative. So cosine is negative. And remember, tangent is sine over cosine. So if sine is positive, cosine is negative, my tangent's going to be negative here too as well. Okay. And then my, that means my sine is positive. Okay. So if I have a point down here, I still have a negative x value and a negative y value. Okay. So both my sine and my cosine are negative. Sine's negative, cosine's negative. And if my tangent is sine over cosine, I have a negative over a negative, so my tangent would be positive. Okay, and last but not least, a point over in this quadrant would be a positive x value and a negative y value. Okay, so my cosine would be positive. Okay, my sine would be negative, and if tangent is sine over cosine, a positive over or negative over a positive, that would be my tangent is negative as well. Okay, so basically, all the functions in the first quadrant are positive. Only sine in the second quadrant, only tangent in the third quadrant, and only cosine in the fourth quadrant are going to be positive. Okay, one of the ways I've learned to remember this, and I want you to conceptually understand it too, is all students, I know this isn't an accurate statement, take calculus. Okay, if you can remember these 4 words and start in quadrant 1, that means all students take calculus. Okay, so that means all of our trig functions are positive. Our sine is positive in quadrant 2. Our tangent is positive in quadrant 3. And our cosine is positive in tangent 4. All right, so let's look at example 4 here. We want to evaluate these two things. Okay, I always like to graph it to kind of give me a visual. So negative 240 is here, right? And we go this way. There's 180, so 240 stops right there. And my reference angle, which is right here, right? If this is 180, this is 240, that means this has to be 60 degrees. Okay, so what I have is a 60-degree angle. Now, if you have the unit circle and you can figure out this point here, you can automatically find tangent by sine over cosine. Okay, but if you don't have it memorized, which is okay, you should know your ratios of special triangles and know that our radius is 1. The small side is always going to be half of that. And then this side over here is going to be the small side times square root of 3, so square root of 3 over 2. Okay, here's my reference angle. Okay, so the tangent, remember, is opposite over adjacent. So tangent of negative 240 is going to be square root of 3 over 2 over 1/2. So if we simplify this, remember when you divide by a fraction, it's the same as multiplying by the reciprocal. Okay, so 2. So this is just square root of 3. Okay, now the last thing we need to do, all students take calculus, is to figure out the sign of this. Well, sine in the second quadrant is positive, everything else is negative, so our tangent would be negative square root of 3. All right, let's look at B now. Okay, so B is, remember cosecant is 1 over sine, so this is 1 over sine of 17 pi over 6. Okay, and if I draw this out, okay, so think of this as just short of 18 pi over 6, which would be 3 pi. Okay, so I would go, there's 6 pi over 6, 12 pi over 6. 18 pi over 6 would be on the x-axis, so it's just short of that. Okay, so my reference angle here would be pi over 6. Okay, now you should know by now that pi over 6 is equal to 30 degrees, if you think of it that way. So this is essentially a 30-degree angle. Okay, so we know that in the unit circle, my hypotenuse is 1 because it's the radius. The short side is always half that, and the long side is always the short side times square root of 3. Okay, so if I want to find the sine of this, 1 over, the sine of this would be opposite over hypotenuse, so just 1/2 over 1. Okay, which is just 1 over 1/2. And once again, anytime I divide by a fraction, I multiply by the reciprocal, so this would be 1 times 2 over 1, which is just 2. Okay, now the last thing we need to do is we need to check our signs. So quadrant 1, all things are positive. All students take calculus. So in the second one, our sign is calculus, so this is 1 over sine. Or sorry, our sign is positive. This is 1 over sine, so this would be a positive 2.